have to come from one triangle only. All sides at the bottom have to come from the other triangle only. Step by step, let's start with the common angle. What is the side opposite to the common angle in the small triangle?
2.
Very good. What is the opposite side of the same common angle in the big triangle?
Y.
Thank you. Moving on. I will not use this because who cares? I don't have this. I will not use this. Who cares? I don't have it. So I'm going to skip that. Moving on to this angle, which is the same with this angle. In the small triangle, I have to always go back from the beginning to the same triangle. So what is the opposite side of this angle in the small triangle? That's it. What is the opposite side of this congruent angle in the big triangle? That's it. That's all I need. I found the relationship between x and y. It's a proportion. What do we do in a proportion? What can we apply in a proportion and only in a proportion?
Cross multiplication.
That's it. That's it. This times this equals this times this. So then I have xy equals 24. Ready for differentiation? Remember, x and y are functions of time. X and y, functions of time. So let's differentiate. Can anyone give us an answer here?
Would it be x dx over d?
So when you differentiate x, it's a function, right? You only have dx over dt times y plus x times
dy dt.
That's it. And I have to have an equation. What is the right-hand side?
1. No.
0.
That's
Is it
it.
0?
Sure. So now we are solving for dy over dt. So this goes to the other side and I divide by x. So then dy over dt equals negative y over x dx over dt. And now I'm happy and I can say when x is 8. Not before. So when x is 8, then I know this is 8. This is given to us as 1.6. But I have to determine y. That's a piece of cake. Because if I know that this is 8, when x is 8, and this is 24, how much is y?
3.
That's it. So I have negative 3 over 8 times 16. I simplify, and I get negative 6. Measurement unit.
Meters per second.
Decreasing. Ah! Okay, it's 1.6. I wish I could walk that fast at 16 meters per second. So 1.6 meters per second. So I'll simplify, so this is 0.2. So negative 0.6 meters per second. So as the person approaches the wall, his shadow on the wall is decreasing with 0.6 meters per second when the person is exactly 4 meters away from the wall. This is just the particular instant. This is not forever. This is exactly when he is had covered the distance of 8 meters. This is exactly for a particular instant. Any questions? Do we understand each step here? Yes? No one says anything? Let me plug my computer in because I think it's getting low. Okay. So let's take a look. Baseball, particle again. Let's look at the gravel.
Can we write the steps out?
Yeah. So the steps are: number one, a graph. Number two, come up with an equation in which everything is involved, all the functions, 2, 3 functions, I'm not sure, depending on the problem. Number three, differentiate. And number four, plug in all the numbers you have.
And then when we're testing on this, you would expect to see those 4 steps.
Yes. So you have to have some sort of graph. Otherwise, you will not be able to come up with anything. Okay, so here we have, that's 29. So we have a cone. Let me graph it. Okay, so let's read it. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute. I'm going to ask you in a minute, what does that mean? And its curvature is such that it forms a pile in the shape of a cone whose base diameter and height are always. This I have to take into account. The base diameter and height. So the diameter and the height are always the same. So this is the diameter. I'll stop sharing in a second. And this is the height. This is taken into account because it's always the same. How fast is the height of the pile increasing when the pile is 10 feet high? When 10, right? 10 feet high. Good. So I'm dumping sand, whatever I'm dumping, and it's in the form of a cone. It has a base, which is a circle, has a height, it has a diameter. This is the radius, twice diameter. The diameter is twice the radius, and I am told that this, as long as I dump and dump and dump from the conveyor belt, these two are always the same. I have to take this into account from the get-go. And this is the same with 2 radii. Let me use the same notation so it's not confusing. Okay, first of all, what is given in the problem? I need to identify what this is because that's my starting point. So I came up with a graph. The graph was given to us in this case. And now I'm thinking of an equation. But it depends on, I have to identify what is given in the problem and what am I asked. And then I'll come up with that. So what does this represent?
It's dv dt.
Thank you. Why? How do I know? It's power 3 for feet. It must be the volume. Okay? dv over dt is given in the problem. Excellent. So now here we're asked, how fast is the height changing? How fast is the height of the pile increasing or changing, increasing? So I expect a positive answer when the pile is 10 feet high. So they want us to determine the instantaneous rate of change of the height exactly at the moment when the height is 10 feet. I don't care for this, not till the very last step. But I need to understand what I'm asked to determine. Because then I'm on a wild goose chase. I need to know what they're asking me to find. So what am I?
dH/dt.
Of course. Thank you very much. It is dH over dt when the height is 10 feet. Excellent. Where is my starting point? So I'm working on the equation right now. Where is my starting point? What do you think I need to come up with or start with?
The relationship between H and V.
Yes? So my starting point is the volume of a cone.
The volume formula.
Exactly. Awesome. Very good. So let me remind you for the cylinder, and you can say, what are you talking about in a second? So the volume of a cylinder is the area of the base, pi r squared, times the height. The volume of a cone, same thing, but divided by 3. So 1/3 pi r squared height. So easy to remember them together. The cylinder area of the base times the height. This is the same thing, but 1/3 in front. So that is my starting point. So the volume. So I'm going to write it again. So the volume equals pi r squared times the height. And now I'm using small r, and I used, okay. So I'm going to erase it from here. It's lowercase r. I don't want to confuse it, and these are two different things. So I'm going to erase it from here. And erase it from here. Okay, so I use lowercase r. So this is r. So, and we also know that the height equals 2r and equals the diameter. Okay. I do not have any information about the radius, right? I only have the volume, the rate of change of the volume. I'm told from the very beginning that the distance equals the height. So I need to make some changes here because I do have information about the volume and I don't have any information about the radius. And what I'm interested is in the height. So the height has to stay, but the radius somehow has to disappear from here. And I know that I can change the radius solving this equation for r, then it's h divided by 2. This has to go. It will be replaced by h over 2, everything squared. Good, so then the equation is volume equals, sorry, I just said that and I didn't write over 3. So h squared divided by 4 times h. So pi over 3, the radius squared is basically the height over 2, so I have to square this, and then multiply by the height. So then this is pi divided by 12, h to the 3rd. This is the equation I need. I don't need anything else. Let me write it again. Pi divided by 12, h to the 3rd. And now I can differentiate both sides. Remember, v and h are functions of time. And they have to be treated that way. So let's differentiate and plug it in. And that's it. The left-hand side.
dV dt.
That's it. The right-hand side.
Squared. DHDT.
Thank you very much. This is what we're after. I will simplify. I multiply both sides by 4 and divide both sides by pi h squared. dh over dt equals 4 over pi h squared dv over dt. Now, yes, only now I can write h equals 10. Any questions before we plug it in? So 4 over pi, 10 squared is 100, times dv over dt, 30. So this is 6 divided by 5 pi, whatever that is. 6 divided, put in parentheses please, 5 times pi. Approximately 0.382 measurement unit. Measurement unit.
That would be
Feet per minute.
feet.
Feet,
Yes, feet per
feet per,
second.
it was minute, but yes, that's perfect. Yes, please remember, you have to look here. Feet per minute.